All right, we got Bryce. Say your last name?
Croucher.
Bryce Croucher. Kolton Martin. We met the other day over at our mutual friends' game party, and he thought you would be an interesting guest to have on the podcast. Could you tell me in some sort of detail what it is that you do?
Sure. Yeah. Hopefully my friend was right. I guess we'll see shortly.
Mm-hmm.
But yeah, pretty much right now what I do is I build robots. I'm basically working for a company in Europe,
mm-hmm.
trying to design and build a machine that will go to the International Space Station
mm-hmm.
and conduct an experiment that might be really cool
mm-hmm.
or really not.
Mm-hmm.
We'll see. I guess my official job description or like job title is what is it? It's like a mechatronics and robotics designer.
Mm-hmm.
Yeah, and I guess we can get into why it's that later on, but
mm-hmm.
I don't know exactly which way you want to direct
mm-hmm.
the flow of traffic here.
Mm-hmm. Well, the International Space Station part is the coolest part, in my opinion. Can you explain why it has to be done on the ISS?
Yeah, so the company that I'm working for is essentially trying to develop a new type of glass fiber. And it's a type of glass fiber that has existed actually for quite a while, but we're trying to develop it from something that's an extremely niche product for a really small market into something that will be better in every way than existing glass fibers that are used for everyday purposes,
mm-hmm.
Which would then essentially expand the market for this niche glass to ideally consume the market for traditional glass fibers. But
mm-hmm.
Essentially the special thing we're trying to do is that we're trying to take this type of glass that's currently very niche and make it much higher quality so that it can outperform traditional glasses by essentially reducing the amount of crystallization that
mm-hmm.
happens when you create the glass fiber.
Mm-hmm.
When you make a fiber out of glass, it essentially involves heating up the glass till it becomes very soft and pliable, maybe like taffy or something, and stretching it out into a thin fiber. And when you do that with traditional glasses, which are made of silica primarily, you get just what you would expect, a very long, straight, consistent diameter strand of glass. But this niche glass that we're trying to make work is it's called Z-blan. And effectively, when you do this process to Z-blan, it doesn't just become a really nice, uniform, beautiful, clear piece of glass. It becomes a thin piece of glass with a whole bunch of crystals forming inside of it. And those crystals, not being glass, don't transmit light the same way that the glass part of the fiber does. And they cause problems for the performance. And effectively, there's been some research done that shows that when you have a crystal forming process in zero gravity, the crystals are inhibited from forming most of the time, mm-hmm. and at least to a large extent prevented from forming until there's some sort of disturbance that allows them to start growing. So like in zero gravity, if you had this bottle of water and you cooled it down to just below the freezing point of the water, it's quite likely that without some sort of disturbance, it wouldn't actually freeze into a solid. It would remain as a liquid, effectively because, well, there's many theories for why exactly this is, but the point is that we're trying to take this glass that really doesn't make a very good fiber optic glass because it crystallizes, put it in space where it won't crystallize and then make a really high quality product out of it. Because in theory, this glass has a lot of material property advantages over regular glass. The two big ones being that it can be more clear than traditional glass. That's effectively, it has a lower attenuation. That's what the property is called. And it also transmits light over a wider frequency range. So you can transmit, primarily it goes into a longer wavelength spectrum than traditional glass.
And the only use case I know for this stuff is for fiber optic cable. Are there other use cases that you're aware of, or is that simply the only one?
So the use cases, it really all that we're making is fiber optics currently. But fiber optics actually have a really wide range of use cases. And to be honest, I don't know all of them. But
sure.
I do know pretty much anywhere you're transmitting light, fiber optics are a great way to go most of the time. I mean, unless you're talking about lensing, imaging. Even sometimes for imaging, you want fiber optics. But like if you're creating a laser, I'm sure you've heard of a fiber laser.
I actually haven't.
Well, if you haven't heard of a fiber laser, it's effectively a laser that is formed in a fiber and then also transmitted by a fiber. And so a lot of times if you...
A laser for cutting things?
This is one application of a fiber laser. There's other applications as well. But yes, if you were to purchase a machine that's going to cut out shapes with a laser, there's a pretty decent chance that will come with a fiber laser on it. And so if you wanted to have a fiber laser that produces an infrared light, which is a long wavelength form of light compared to the visible spectrum, Z-band would be a great way to do it. Even in the current form where it's created on Earth and it has a bunch of crystals and defects, it still is likely going to be able to do more than a traditional form of glass. And there are other options out there as well besides Z-band. But yes, so that's one example of a way that fiber optic cable is used. But yeah, it's also used for transmitting information, which is a big one because effectively in the current way that the internet works, all large amounts of data are transmitted over glass fiber cable. And that continues to be more and more the case as time goes on. It's just able to transmit more data more quickly than traditional electrical cable. And so the goal ultimately would be to replace all telecommunication cable with Z-band fibers that would be potentially manufactured in space. It's ultimately just one big research expedition, but it's one that could potentially have some exciting effects on the world. And so that's kind of what captured my, I guess, imagination, you might say. Yeah, so that's kind of the current project. And it's definitely a high pressure environment because the company I'm working for isn't the only one trying to make this kind of concept work. And
are you aware of how many competitors there are, at least that how many are you aware of?
So there are on the order of 4 or 5 competitors, but they kind of are varying levels of committed and varying levels of existing success. And I think there are others, but yeah, there is some secrecy in the industry for sure. And yeah, there are some competitors like Made in Space that they are working on like 3D printers for space and a bunch of other things. And their fiber optics division, as far as I understand, may actually be shut down. But it was just one component of what they were working on. Whereas Flawless Photonics, which I don't remember if I mentioned the name, that's the company I'm working for.
Flawless
Photonics.
Photonics.
Yeah, like optics. We're currently focused entirely on doing one thing, and that's making better glass fibers by making them in space.
Is the issue, so if I understand this correctly, the issue that you're trying to solve is when you create fiber optic cables, they tend to crystallize, is that correct?
Yes. When you make them out of this material that we're trying to use that could have benefits over traditional materials, there's many issues with it, honestly. It's quite a difficult material to work with, but the primary one is that it crystallizes very readily.
Is that an issue of the current standard of making fiber optic cable? Does that also crystallize? Is that an issue, or has that been solved in its own way?
Yeah, so the standard materials that are used for glass fibers are in large part chosen, well, obviously one for their clarity and two for their ability to be turned into a glass fiber without crystallizing. And so it's in industry and practice, it's not really a significant issue, and it doesn't contribute notably to their attenuation, their essentially power loss over the distance traveled in the fiber. But those glasses that are used can still crystallize, and I don't know about all, I'm sure not all, but effectively all glasses can crystallize. If you get them to the right temperature and you leave them there long enough, they'll crystallize. And this is one of the things that we figured out firsthand during testing, because effectively this team that I'm working with is all people from industry, some from space industry, some from robotics industry. But we're not really like glass material scientists, experts for the most part. We didn't really have anyone on the team when I joined that had ever created a glass fiber in prior experience. And so one of the things that we did early on is purchase a draw tower, which is a machine that's used on Earth to create glass fibers. And effectively, we purchased one that is much like a university might purchase for research purposes. And we just started doing glass drawing. We didn't even have, great materials to run. We didn't have any Z-Blend to test with. But we just started.
How many tests have you done with the Z-Blend? Is that it? Z-Blend or Z-Blind?
Z-Blend. So it's an acronym.
Okay.
ZBLAN.
ZBLAN. Okay.
Yeah, and that basically is an acronym that stands for the elements that are present in the glass. And you notice 5 elements. Effectively, we can get into the details of the science of it later on, but that's what's in it. There's zirconium, there's beryllium, lanthanum, I can't remember the other two, aluminum, and not remembering. Could be nitrogen, but I'm not sure what the N is. Anyway,
but how many tests have you done? That's a great question, and I don't have an exact number off the top of my head, but the supply of Z-Blend is definitely an issue for anyone trying to tackle this problem, because developing a process to manufacture Z-Blend fibers requires having Z-Blend material to turn into fibers for testing. And it's because it's such a niche market right now, there isn't a large global supply of the raw material. And getting a hold of the material for testing is fairly difficult. But I'd say, we've probably used maybe 25 or so preforms so far, which is, in the scale of the Z-Blend industry, a lot of glass. Do you know how much one one cylinder of Zeblan is?
Yeah, so that depends on where you get it from.
Mm-hmm.
And we get ours from multiple different suppliers in order to basically get as much as we can get a hold of. But they range, typically the size you'll find that's pretty normal is maybe around 12 millimeters or half an inch in diameter and 12 centimeters, would that be 5 inches-ish in length? And they run from maybe $3,000 to $10,000
a pop
per rod, yes. And so running tests on its own is an expensive proposition, but it is expensive money-wise, but even the cost as far as to the project, as far as the human resources and the time in the project schedule that it takes up is rather expensive because we can only get so many before we have to launch. So if we want to run a test, it needs to be very clear what we're planning to learn from this test. What's the optimal outcome? And
what are the different things that you're testing for in each run?
So that really depends, and it changes over time, and it changes by what machining we're running it in. And I mean, we've run tests for many different purposes, but I'd say if I were to kind of generalize and categorize them, it's usually either some sort of material science or general science of drawing glass question we're trying to answer, or it's some sort of machine-specific kind of testing to make sure that our machine that we're designing is going to function as intended.
And the machine is basically meant to heat up the material and then somehow draw the material out of the oven and then spool it into something that you could unroll and create a line with.
Yep. So effectively, yes, we are taking a rod, heating it up, stretching it out, and winding it onto a reel. That's the basic premise. I mean, that's how all glass fiber is effectively made, to my knowledge. I mean, I guess if you get into fiberglass like insulation and some other niche options, there are different ways it's done. But you're talking about, fiber that's meant to be a specific uniform diameter and transmit light. I believe that's pretty much how it's done universally. And our primary challenges, well, there's a really large amount of challenges, but the one that first becomes obvious when you want to make a machine that does this on the ISS is that the existing machines are quite large. If you look at Corning, which is probably a name most people recognize.
Say that one more time.
Corning.
Okay.
Yes, They are a company that does glass. They do all sorts of glass, like the glass on your phone screen could quite well be Corning. People probably have heard of Corningware, which is like kitchenware made of a durable glass. So they're pretty well known for all sorts of glass, but they are also one of the premier manufacturers of optical fiber for telecommunications. And their draw towers are absolutely immense because when you're making glass fiber
Can
on
you compare
Earth,
it to like any like the first thing that comes to mind is a water tower. Like how does it compare to a water tower?
I'd say, that's in the right order of magnitude for sure. It's different ones are different sizes, but the big ones are probably near water tower size. They're several stories tall and, the size of a building in diameter as well. And then they have a building built around them to support them.
And the machine that you're currently building, the prototype, that's not going to be the size of a tower. It's going to be the size of how would you describe that?
So it'll be like smaller than this table that I'm sitting at. I guess for people in audio, it's 0.8 meters by 0.6 meters by 0.4 meters ish.
And can you describe that for an American?
Yeah, so that's like, oh gosh, that's maybe it's a little less than 3 feet by 2 feet by 1.5 feet, something like that. So pretty small box. And the reason for that is it needs to fit somewhere on the ISS and be able to be handled by the astronauts and operated.
If this works, if this works and this becomes the new industry standard, do you expect that would also be using giant water tower like facilities to be able to make this, or is it going to be scaled down in comparison to the industry standard?
I'd say that if it becomes a new industry standard, there will be entirely new design pressures put on what is a fiber manufacturing system. Obviously, the current towers are manned by teams of people, and usually there's, basically some like artisans that really know the machine that are getting it going and making sure that parameters are tuned in manually in person, watching what's happening, and physically working with their hands to make things work. And that's not really practical in space. And also the size and weight of current draw towers are really impractical to send to space from a monetary standpoint. Now I think is a great time to be looking at Z-band again, especially in space, because the cost of launching things to space and the capacity that humans have to send things into orbit, it's much cheaper and there's much more of it happening.
And you described your expertise as robotics.
Yeah.
How does that apply to this project?
Yeah, so the other thing that is a very different design pressure is that it'd be very expensive and impractical to send people up with the machine every time you want to run it. And so essentially, ultimately, whatever makes something in space, if you want to make it for a profit, it should be fully autonomous. And so our first test run may not be completely autonomous, but there's going to be a lot of automation involved. And so I do a lot of designing of mechanisms to help automate the process of making glass.
And as far as I remember, the astronaut in the ISS is going to have a job dealing with your prototype. Can you explain what they're going to have to do?
Yeah, basically, I don't want to get into too many design details, but I think it's okay to say that basically they're going to have to, at the very least, replace the rod of glass when it's expended with a fresh one, and they'll need to...
Do you know how many you guys are going to try to get done?
I think I'm not going to say that.
Yeah, that's fine. Yeah.
I think it would probably be okay, but it's better to play it safe.
More than one.
Yeah, this is why there's a reason. There's stuff for the astronaut to do, but they would effectively replace the glass rod, and they would replace the spool that the fiber is drawn onto. That will allow for more than one run to happen on a single mission. And that's really just for, again, this is essentially an experiment, and we want to be able to do multiple runs of experiments when we're on the ISS. We need to make the maximal use of the time and space that we have there in order to learn as much as we can about how the process works in zero gravity. Because a lot of time and money goes into getting a spot on the ISS. And I think that's a pretty decent overview of what we're doing, what we're trying to do. I don't know how much interest you have in like how I got into this position.
Well, let me try to explain what it is that I know, and then you can fill it in.
From now on, only the captain says "arg."
You're from around here, Hawkinson. You grow up in doing like a high school robotics team. Is that correct?
Yep.
You and a friend both compete, and somebody who is either a parent, coach, is affiliated with this company in Luxembourg and is recruiting people who can possibly do this job, and you guys are candidates. So he reaches out to you, and that's the rest of the story that I can relay.
Yeah. I mean, I think that's pretty much it. There's, I mean, we could go into endless detail for sure. But I did actually start building robots even younger than high school. The program that we competed in is called First Robotics. Mm-hmm. And
would you mind trying to get a little bit closer?
Yeah. Hopefully I don't make it too difficult on you in post.
Yeah, well, I have no idea how this is gonna. This is my first run, so.
Yeah. We'll guess find out when we hear afterwards. But if there's one thing that I could relay to your listeners from my experience, it's that you should do First Robotics if you're interested in a career in STEM, science, technology, engineering, or math.
Is this a nationwide kind of affiliated thing, or is this a local? Okay.
It's actually an international program with the majority of teams being American or North American. And yeah, so I started in the Lego Robotics program.
Sweet.
Yeah, which is a fantastic program. I must say I had an absolutely great time. It totally kind of sparked the fire within me to work on hands-on robotic things. It really showed me that I was able to do things that are cool and interesting, and that I could have fun doing it. And I did that from 5th grade through 8th grade. Had a fantastic time. It was basically a small team that my cousin and I started with a few of our friends.
How close is the nearest team to you guys?
For middle school age?
Whenever time period we're talking about, so if that's what it is, then yes.
Yeah, I actually don't know. And that's the thing about FLL, is that it's designed to be very cheap and easy to start up a team. And it's also not so easy to find nearby teams. If you go to, if your child or someone goes to a elementary or middle school, that school might have a team, and you could look into joining that. But as far as community teams, there's not really a lot of information out there about, where they meet, what teams there even are, to be honest, at least when I was looking. And this is ultimately what led to my cousin and I basically starting a team. But it's really not too difficult with a little bit of parental support. It really only costs a few $100s, I think, to get going on an FLL team. FLL is the acronym for the Lego program. It's the first Lego League. And that's a great place to start.
What kind of projects are you making?
Yeah, so essentially the challenge is something like a 4-foot by 8-foot competition field, something like the size of these 3 tables put together, maybe plus a little. There are essentially challenges also built out of Legos that your team constructs a Lego robot to essentially, there's usually one spot on the field where you can touch the robot, get it set up, and hit go. Then the robot does autonomous missions to...
That's a 30-minute mark.
Okay.
Should be good to go. Yeah, I'm not going to mess with that much. All right.
You did warn me about that.
Yeah.
So, from the top, the challenges usually consist of a field that's 4 foot by 8 foot roughly, with a essentially home base marked on it, where the students can manipulate the robot and get it lined up and calibrated and started up. And then when the robot leaves the base, it has to operate autonomously on its own. And there's a bunch of different mechanical challenges that the robot can complete for points out on the field. Might be something like picking up a box from one location, delivering it to another, or pressing a plunger with a really specific amount of force, where if you push it too hard, it doesn't give you the points, and if you push it too soft, it doesn't give you the points.
Like if you destroy it, no points for that.
Yes, there's all sorts of rules about stuff like that. But there are lots of different challenges. Some where you have to track down pieces that can move around, like balls that roll and things like that. But effectively, there's just a bunch of these challenges. The robot has 2.5 minutes. The team has 2.5 minutes to get the robot to complete as many challenges as possible. And you can return to the base and start again as many times as you like. But if
there's no, like, you can't have a remote control.
There's no remote control.
Okay.
Once the robot has even begun to leave the base, typically, you can't touch it, you can't influence it in any way. And the robot operates autonomously until it returns. And then you tally up the points, and they say that it's about more than robots, but it really is, because in this competition, the robot points are not that important. It's a great thing to get kids excited, and it's super fun. But there's also judging about kind of the design of the robot, the process that was used to develop it and tune it. And there's judging about the teamwork of the team, how they work together.
Do you remember what your guys' robot, do you know what challenges it completed?
Yeah, so I competed 4 years, right? 5th grade through 8th grade. And the first 2 years, we really just focused on the robot, and it was really not very good.
Are you taking the same robot to each competition?
No. Typically in FLO, I mean, I think you can do more than one, but oftentimes you just have one event that's near you. You bring the robot, you do your best, and if you do well, you can qualify for the next level of competition. And if you don't do well, see you next year, pretty much. Which can be a bit frustrating, especially if you just barely don't make it to the next level. But when you do make it to the next level...
Is it like doesn't matter, is there like a top 3 go, or is it like anybody who makes this threshold goes?
So I'm not sure what they do anymore. In fact, I'm having a hard time remembering exactly how the advancement worked before, but I think it was basically a top 3 go kind of thing. And yeah, there was like maybe an exception for like one specific award for like best teamwork or something might also go. But effectively, there was like 3 main components. There's the robot scoring on the field. There's the like teamwork, core values aspect. And then there's a science project, basically a research project, which is quite interesting that they give to middle schoolers. But it's amazing the things that they show up with. And so the first 2 years I competed, we really focused on the robot. The robot did quite poorly. The other stuff we didn't focus on.
Are you getting a lot of guidance from like your fathers while you're doing this? Or is it
so
like, boys, figure it out, you got to do it?
The parents are allowed to effectively coach, but they're really not allowed to do anything themselves. And they're also really discouraged from like convincing the kids they must do it a certain way.
Sure.
So ultimately it's up to the kids, but if the kids have questions, they're allowed to answer, obviously, and they might give some suggestions along the way to try and, or even some prodding questions to get things moving in the right direction. But when you go to competition, the judging only is for the kids. There's no parents involved. And so when they ask about the process of how the robot was developed and how it works, it becomes quite evident whether the kids designed the robot or not.
Yeah.
And so that's, I mean, part of why they do it this way. But so getting back to your question, the first 2 years we did very poorly on pretty much all fronts. Although we did always end up with some sort of award, but it was not too commendable. The third year we said...
Did you go into the competition knowing like, we are going to we're going to blow this. This is
We
not going to
had
work.
no idea.
Okay.
We were very new, to the whole thing. Like we've never really built robots. We played with Legos before, but the second year we kind of had some idea, and we knew that we weren't probably going to be taking home the number one prize, but we weren't exactly sure, And the third year, we said, we typically do a good job of focusing on the robot side, even if we're not the top performer. But on the science project side, we never really showed up with anything too compelling at all. And it was mostly because the kids didn't care about it. We weren't excited about the science fair thing. So we said, let's build something that is exciting and then make a project about it. And so for that year, the theme of the science projects was transportation. You had to do some sort of transportation-related research. And so electric cars, making your own electric cars was already kind of a thing. This was like in 2009 or something. No, maybe later, 2010. I don't know. Anyway, we decided that we would try to take a riding lawnmower that was powered by petrol and convert it to run on electric. And definitely this was something that captured our imagination and excitement. And we worked hard on it. We went to local forklift dealer and found some components from a old decrepit electric forklift. And we took like the whole controller board that drove the motors. It was like something that would effectively dole out the power to the electric motors. And it, had a whole bunch of high current switches built in and some high current wires. And we also took one motor that was still good, that was a big, maybe 130, 150 pounds of steel, was a DC motor. And obviously, some things like delivering the motor to where it needed to sit was not something for the middle schoolers. But
Sure.
Ultimately, we worked together to convert this lawnmower to electric. We made a project about it. We were super excited.
Maybe it's obvious, but this is no longer in the Lego realm, or are you still using Lego components when you're doing this?
No. So it's for the Lego League competition, but the science project, you can really do whatever you want. The only thing that has to be made of Legos is the Lego robot that competes on the field.
Okay.
And yes, so we were we didn't make many parts for this. We didn't have to make many parts, thankfully. We basically took the grass catcher that went in the back of the lawnmower, and we put some plywood plates down so that we could have like 2 levels. And then we put some deep cycle lead acid batteries that we got used somewhere for super cheap. 4 of them.
Is this the same thing that it was in like 6th gear when you turned it on?
Yes.
Okay, can you actually
Yeah.
go into the story right there?
Yeah. So effectively, you've got a riding lawnmower, right? And this might be a little bit hard to visualize from the audio, but in the front, we took out a gas motor and we replaced it with a electric motor. And so it might have become slightly heavier on the front, but not by too much. But then in the back, you've got basically plastic with a few metal supports, grass catcher that's just empty, catches grass. And we replaced that with 4 deep cycle lead acid car batteries to get the necessary voltage to run the motor. And that added a lot of weight, and it was hanging off the back of the basically lawn tractor. And so this meant that a lot of the weight was on the rear wheels already. And what we didn't realize...
Is it rear wheel drive?
Yes.
Okay.
Yeah, so it's a rear-wheel drive lawn tractor. And what we didn't really realize when we were first starting the thing up is that the transmission was not some sort of smooth, controllable transmission like you might see on a modern lawnmower. It just had a throttle for the gas engine, and then it had a manual transmission to shift gears, and it had 6 gears, and we didn't even realize the transmission was there, really. So when we first started it up, And we also didn't have a way to throttle our motor because
It was just on or off.
A motor that big, I mean, the controller board they used to throttle the motor is what we cannibalized from the forklift, but it wasn't working, and it was the size of this table. It wasn't going to fit in this lawnmower. So we just took one switch out of it that was able to switch the power on and off, and we used that. We connected it to the key that would start the normal gas mower. So when you started the key, the switch closed and you were full beans. There was no in between. So when we first started this thing up, we didn't think to check what gear we're in. We were in 6th gear, of course. And my friend was sitting on the lawnmower like, okay, here we go. Turns the key. Sparks fly everywhere because there were tons of connections that were not capable of handling this much power.
How close are the sparks to the seat? Like, is he near getting burned, or is it like out the back? Where is it at?
I don't remember. It was all over the place.
Sure.
Like in my memory, it like blotted out the sun. I mean, it was
really.
yeah. I don't think that's quite how it happened, but it was a lot of sparks showering the driveway, and the thing popped a big wheelie, just totally on 2 wheels. I think the back batteries touched the ground and then it popped back down as he lurched forward. And the thing also like shut itself off. One of the connections, it wasn't good enough, like basically vaporized itself.
I see.
And then it died.
Well, so it was almost a good thing that it shut itself off.
Yeah, he didn't just continue on into the sunset at maximum speed.
How far did he make it?
Basically to the end of the driveway, which is pretty short, maybe 15 feet or something.
But it was a thrill of a ride for that 15
That's
feet.
for sure. Everyone was certainly excited and also horrified. But
are any of the moms out there?
There was not. This was only the dads,
Good.
And they were all laughing with us once we got the thumbs up from our driver. So it was quite a time for sure.
Is he wearing any safety equipment, or is it just like, just give it a shot?
No, I think he had safety glasses. That's about it.
Yeah.
So I guess probably sparks weren't going to get in his eyes. But other than that, there wasn't too much. Definitely wasn't the safest or smartest thing I've ever done, but it is definitely a lifelong memory.
How many test runs do you run after that before it's like, okay, we've got this in the way that we need it?
I don't know, maybe a dozen or so. Primarily, the thing we changed is going from a grounded frame. So we had 48 volts and a whole booty load of amps going through the chassis of the lawnmower, which was a very poor decision in hindsight. And we went to having actual ground cables for the other side of the circuit. And we did eventually rearrange how the batteries were attached so that there was basically 2 in the back and 2 in the front. And that definitely helped with the whole balance and popping wheelies thing. And then we also added a note to put it in first gear before you start it. And with those 3 changes, it became much more manageable. You still, like once you got up to speed, you might be in 4th gear cutting grass. You really can't slow down without just shifting out of gear. So it wasn't the most practical lawnmower. But it was able to mow my lawn, which was maybe 2 or 3 acres.
That's actually one thing I was interested in. It's like, did you guys keep the blade in it or not?
Oh, yeah. It had a blade. It didn't cut grass. And, we wanted to show that it could be a superior alternative to gasoline in a few ways. Mostly we wanted to show that it was quieter. And
did it have a ability to recharge, or did you have to go in and put new batteries in every time?
So putting new batteries in would have been a real chore because those things were huge and heavy. But we ended up finding a 48 volt DC charger, and we didn't have any balance charging, which is probably not a good thing in the long run. But effectively, we just balancing is like making sure that your batteries that are wired in series, that they have all the same voltage. So when batteries are in parallel, they're essentially connected across the leads. They have to have the same voltage. But when they're in series, if one has a little bit more resistance than the other from manufacturing tolerances, you can get one battery that's like completely dead and the other one's charged. If you discharge and recharge it over and over again, and you never check on it.
When you're,
But
when,
we
when
didn't
you,
know about any of that stuff as middle
Sure.
schoolers. So we just took the leads. We brought them up.
well,
near
did
the,
your dads have any idea that?
my dad was a programmer, and my cousin's dad was also a programmer. And I think we had another dad helping who was in construction. None of them were electrical people. So no.
Fair.
Yeah. But effectively, we just ran some wires up to near the dashboard and put a plug where we could connect a 48 volt charger. And it take a while, but you usually mow once a week, so it would definitely charge in the time we had. We talked even about trying to do a solar charger, but obviously it was quite an ambitious project already, and we did not have the time for that. And then ultimately, we also thought we had a decent robot that year, despite spending less time on it. Had some more experience, and we're doing a lot of work using light sensors. Effectively on the table where you're competing, there's a mat with lines and colors and different things on it that sensor facing down can detect the light spots and dark spots and help the robot to know where it is on the field. Because ultimately, when the robot's operating autonomously, one of the biggest challenges is knowing where the robot is.
The missile knows where it is at all times. It knows this because it knows where it isn't.
And we did a bunch of work with that, but then when we got to competition, we found out that we had 3 light sensors on the bottom of the robot looking down at the mat, and there was a rule saying you could only have 2. And
What's the role of a licenser?
so like I was trying to describe earlier, it's basically looking down at the mat, and it's telling the robot, is it looking at a bright piece of mat? Is it looking at a dark piece of mat? And the mat has things like lines on it that you can use as a reference. So if you're on the far side of the field, you've been driving quite a while, the robot might not be quite where you expect, but if you put in the program, drive forward until you see a dark line, then you know, okay, I'm on that line. And you can use that as a reference to...
Will the line, like if you tell it to follow the line, will it eventually lead it back to the start?
Typically there are not lines that lead all the way to the base, but there are typically lines that are useful to follow along, and we definitely had that capability as well. Basically riding the edge between the dark and the light, and then if it gets too light, it turns one way. If it gets too dark, it turns the other way, and follows it to the end of the line. But yeah, we were a bit disheartened to find out that we had to remove one, because we looked at our missions and basically almost every mission used all 3. So there wasn't one we were going to remove and just only lose one mission, you know. Anyway, we took one off and we competed and it was okay. But
this is year 3?
Year 3. And we didn't quite make the threshold to move on. Although we did get the Best Project Award, which was not a qualifying award on its own. And so we went home. We had fun, but we thought, this is our last year, you know, in between 7th and 8th grade, we're going to take it seriously. And my dad was a programmer, and we enlisted a lot of his knowledge and expertise to basically create our own system for doing pretty advanced, like motion controls, stuff that, like if you see a robot picking and placing car parts in a car factory, they're primarily using like motion profiling type controls where there's a plan for the robot to move from where it is to somewhere else, and there's an expected amount of motor power that's going to be required for that, and then it goes along the path and it measures how it's doing compared to expectations, and then makes adjustments to motor powers as needed based on that. And we implemented our own system for this and tuned it ourselves, and did a bunch of testing to basically make our robot able to move as accurately as possible over long distances in the time between the seasons. We were still working, even though we didn't know what the next year's challenge was going to look like. And then my last year, we used these tools that we developed in the off season to make a robot that was really effective, and we did a project again that we thought would be fun. This one was supposed to be about my biomedical research, and we found basically a woman who was missing an arm, after the elbow, and she was having trouble learning to swim. She obviously swimming without an arm is a bit harder.
Sure. And are you in ninth grade when you're doing this?
8th grade.
You're in 8th grade trying to do bioengineering.
Yeah, basically.
That's pretty cool.
Yeah, I mean, that's like what I was saying is that this program, it really pushes kids to do things that you wouldn't expect them to be able to do. But in the end, it usually gets a lot out of them. It really kind of...
How do you meet this person?
So my mom was basically trying to teach her how to swim.
I know someone who can help. If you say your mom, you're fired. My mom! Get out!
She worked at a local health club doing swim coaching, and this woman was trying to learn from my mom how to swim. And, she was learning, but it was also being quite difficult. The typical prosthetic that she had was like the claw shape. And that's extremely hydrodynamic, which is not really what you want for a swimming arm. Like it just cuts through the water, but it doesn't produce any
drag.
Yeah, any bite, any force to propel yourself. And it also would sink, so she would always be worried that it might fall off and sink to the bottom of the pool.
But your life does not. Oh my God, bruh. We gonna keep this? Nigga, I can't even reach it, bro. This is beyond embarrassing. Wait a minute.
They're not exactly designed to be wet all the time, although they are, fairly water resistant. You have to use them all the time. But effectively, we went to a prosthetics expert, and we kind of asked them what we might be able to do to create something that's more effective for swimming. That might be
Where's the expert at? How do you meet them?
This I don't actually remember, to be honest. I should remember, but it's not coming to mind. I think one of the dads must have known him. We basically asked him about what kind of process we might be able to use to make something that's a little bit more buoyant, but almost neutrally buoyant, and something that's sleek and follows a normal.
So you're trying to find a
shape.
balance of you don't want it to continually
Flow.
bring her up, but
Yes.
you also want her to be able to use force to go into the water.
Yeah, and you want it so that if it were to come off, it's not going to sink to the bottom of the
That's
ocean.
good. Yeah,
and
yeah,
be
you
gone.
might want to deal with that. Yeah.
Yeah, so we wanted it to be almost the density of water, but a little bit lighter, and we wanted it to be a nice, sleek shape. And ultimately, he helped us through the process a whole lot. And we didn't have a lot of the machines that we would need to make something like this, so we were using his shop, and he was kind of directing us through the steps, and it was a very cool learning experience.
He let you use his shop.
Yeah.
Okay, that's nice.
Yeah, and
how much of it do you know? Was it a big travel? You had to really plan to be able to go use it, or?
So pretty much we did do some planning, but we ended up making the arm in just 2 sessions. So it wasn't too difficult as far as organizing.
And did you say is it I think of a 3D printer, but is that the kind of thing that you would use to make that sort of?
So at that time, 3D printers were extremely
rare.
Down low. People weren't really using them for much of anything useful. At that time, they were just kind of like a specialty thing and for aesthetics, but anything that you wanted to not snap in half, you wouldn't 3D print.
Okay.
And ultimately, we used more traditional prosthetics techniques, which was effectively getting a mold made of an arm of about the right size and the shape that we want. And also a mold of her remaining of her arm. And then...
is this somebody who's similarly aged to you, or is she significantly older?
She's older. Probably late 20s, early 30s. And yeah, It's like someone who, you know, kind of always wanted to learn how to swim, but felt like they were having trouble because of their lost arm.
Maybe a little intimidated.
Yeah. Mm-hmm. And but effectively we made a plaster copy of the shape we wanted to use. Mm-hmm. We then did just like a vacuum, like suction over it, using a heated sheet of polycarbonate. Mm-hmm. And that made like the shell of the outer case. And we did the same thing for the shell that would match her remaining part of her arm. Mm-hmm. And then in between, we basically filled with a expanding foam, mm-hmm. Like a urethane foam that would be an appropriate density. Yep, and that was pretty much the process. And then we made like a little neoprene sleeve, something like you would find as part of a wetsuit maybe, mm-hmm. that would help cover the joint and make sure that it was like suctioned on and wouldn't fall off. And then we, you know, gave it to her and got some video of her swimming with it and learning to use it, and put together our presentation. Anyway, it was another fun project.
How long was the process of making it? Do you know how?
It was a long time ago.
Oh, no. Oh, yeah, okay. I see what you're saying.
So I don't remember exactly how long it took.
Was it as effective as you wanted it to be?
I would say that in the end, it was pretty effective at doing what we wanted it to do. But I do think it was like a very custom process that, like, if she were to go to someone making prosthetics and ask them to do it for her, it would probably be quite expensive. Mm-hmm. And I don't think too many people would really be worth the expense. Sure. So in that case, I don't know that it's really like a viable product. Mm-hmm. But I do think that for this one person, I think it was useful to her. I haven't kept up with her to know if she's still using it. But
what is the shape of this tool?
Yeah, it's basically like when a swimmer makes the shape of their hand, wrist, arm, mm-hmm. as they're entering and pulling through the water. That's what we tried to copy. Mm-hmm. And so it really just looks like a pale white plastic hand and forearm.
Mm-hmm. Okay.
Yep. Yep. And I would say it was a success in that all the goals we had for the design, it met. Like, it didn't have a bunch of drag when she was pushing it forwards in front of her. It allowed her to get purchase in the water when pulling with mm-hmm. her left arm. And it was not so buoyant as to pull her arm up, but didn't sink when put in the water.
Did it have trial errors where it would fall off?
We didn't see it fall off by accident, but we did put it in the water by itself to test its buoyancy.
Sure.
But yeah, and then it held on, I think, decently well. So I think it did all the things we wanted it to do. I don't know that, the idea was also genius, but
fair.
It was okay. Yeah. And it was
for an 8th grader.
Yeah, it was a fun project for sure. And the judges at our local competition really liked it. And we ended up winning the competition locally and going to the state championship. And we went there for the first time. I mean, the first 3 years, as I described, we missed by a mile and then missed by a mile and then barely missed the state championship. And then the 4th year, we made it to the state championship for the first time. We were super excited to go see all the other teams and their different projects and robots. And
how big is the team?
It varied a little bit year by year, but it was usually around 5 to 8 kids.
Okay.
Usually it was like me, my cousin, and then a friend or two of mine and a friend or two of his.
And it's your cousin that works in Luxembourg with you?
No. So this is a friend who's now a YouTuber.
Really?
Another guy you could interview, perhaps.
Sweet, yeah.
But yeah, he's a really awesome dude. But yeah, he got into YouTube around entering high school, like similar to when we...
Does he have time to...
aged out for the robotics program.
In Luxembourg right now?
Well, he's not in Luxembourg. My cousin, he lives locally.
Okay, you're talking about your cousin still, and I'm talking about the guy in Luxembourg.
Oh, the guy in Luxembourg is someone who I met in high school. Mm-hmm. And
Let's go back to the YouTuber though. I'm very interested in this guy. What does he do on YouTube?
So he's pretty much a gamer. And yeah, he right now I think he is more. Oh,
That is a time to go do the camera again. Okay, so you've got a friend. He's a YouTuber. He plays games. What's his channel name?
Me Like Big Boom.
Me Like Big Boom.
Yep, and he worked on YouTube all through high school, and he was quite good at being entertaining while playing games. I think this is something that everyone in the family knew. We had we got a bunch of cousins on that side, maybe 14 cousins or so, and he'd always be the one on the Xbox, and everyone would be very content just watching him play. It was super entertaining. And when he got to high school age, he started making YouTube videos, and it took him a while to take off, but eventually he got really big and started making enough money. He didn't really feel like he needed to do anything else.
That'd be awesome. That's super cool.
Yep. So that's what he's doing.
Do you know what games he's playing right now?
I don't, to be honest. I should keep up with his streams more, but I haven't been. I know he does some VR stuff. He does some
interesting.
I think he does some racing sim stuff, and I think the big game that was like his breakout moment was Unturned, which is a what do you call that? It's an indie game created by I think a single developer, and so he kind of started making videos for it when it was very small, and it's a game that's a bit difficult to get into. But then it became quite large. It became quite a following. And so all the people getting into it were trying to figure out how to play it, would end up watching his videos. And so it really rocketed his channel to success.
Are you aware of how his social dynamics changed from before he was like big on YouTube to after? Like
that one you'll have to wait for his interview, I think.
All right. I'm interested in that.
I know as, like, for me, he's the same cool kid he always was. But I'm sure it changed some things, for sure. But yeah, you'd have to ask him. I assume, I don't know how he'd feel about doing a podcast. Maybe he'd want me to remove his, like, potential name connection or where he lives. I don't know. I'd have to talk to him. Anyway,
I don't know where he lives.
Yeah, but anyway,
is he anonymous? Like, is his channel like he doesn't use his face?
I think that his
stuff?
channel is anonymous. I think he's done a face reveal. I could be wrong, but I don't think like he's done a name reveal. So, well, I'll ask him how he feels about getting mentioned in this podcast.
See if he wants to do an interview. That'd be sweet.
Yeah, I'll ask him.
And I've got 41 subscribers. Who knows how many actually watch the stuff? I'm not sure how familiar you are with like the conversion between your subscribers and if they actually watch your video. Like, and I'm not so sure that I know specifically, but it's way less than the actual 41 subscribers.
Yeah. Well, he's just getting started, obviously. I'm sure he was in a very similar place at one point. But anyway, he and I were definitely big drivers on this team, and his dad and my dad, my uncle and my dad, if you will, were also quite involved. But ultimately, so we went to the state championship. We competed. We had a great time, and we definitely performed a lot better. The robot did better. The presentations and interviews, we were more prepared, and we felt, we put everything out there, left it on the table. But going to the award ceremony, we obviously had no idea how we'd place, considering we'd never been to the state championship. And we ended up winning the whole thing, which was a huge shock. And
really?
We were super excited. I couldn't believe it, honestly. And
is this still the swimmer's arm? Or is this something different? Okay.
So this is the final year. Swimmer's arm and a robot that had much better controls and software behind it.
Do you win by the total of each project?
Basically, yeah. There's I think there was 4 categories at the time. I don't know if there still are, but it was like robot performance,
Okay.
robot design interview, the teamwork and core values interview, and then the project presentation. And I could be wrong, but I believe they were weighted equally at the time. And yeah, so they just take the sum of the 4 scores, put them in a list, and if you were number 1, you win. And we ended up winning, and so we qualified for the World Championship. Or there was actually World Championship, which was in St. Louis, and then there was the international invite, because there wasn't even to qualify for the World Championship was so difficult in FLL. There are so many teams compared to the amount of slots at the World Championship. Not every state could even send 1 team to the World Championship, and we ended up going to the international invite, which was probably the preferable one for us because it was in Legoland. It actually
That's sweet.
took place within the park. It was something going on.
That's in Florida, right?
Wrong.
It's in California.
California. Okay.
Yep. So yeah, we could go to our robot match, do the robot thing, and then go get on a roller coaster in between. It was quite a fun experience. But got done with that, and wanted to see what's next. What can I do to kind of replace this thing where I was spending an unhealthy amount of my time, and do something building robots, having fun, and learning about myself and about engineering, and found out that the organization that runs the first Lego League also has a high school level program called First Robotics Competition. And so I joined that as a freshman, and contrary to First Lego League, this is an extremely expensive and resource intensive program to start a team in. We're talking tens of thousands of dollars per year, and the first year maybe more.
Do you have to get grants to be able to do this?
Yes, so there's many avenues. You can get grants. You can ask your school for the money, depending on what school you go to.
You can have baller parents.
You can have baller parents, for sure. That's a contributor. And the number one thing for the team I was on is corporate sponsors. So we would reach out to companies locally and internationally that might be interested in sponsoring a high school level robotics team and ask them for money, basically. And then we had, of course, perks for different amounts of donations and things like that. I think companies that donated over $1,000 could get their logo on the robot on a panel with all the sponsors, like a NASCAR team or something. And so I did that as well for 4 years. The team that I joined, thankfully, happened to be quite a successful team already.
Okay.
They had already qualified for the World Championship for the first time the same year that I did, in 2010-11 season.
And they're doing a different competition, though?
Yes, so this is a very different competition. Instead of building a Lego robot that's maybe less than a foot in each dimension,
Okay.
you build a robot that is typically 2 to 3 feet in X and Y, and anything between 2 and 10 or 12 feet tall. And they're typically up to 150 pounds, made of metal, basically whatever kind of construction you want. You can build it out of plywood or metal or carbon fiber if you like. And they're much more human-driven, which is interesting. They typically have...
Meaning it doesn't have to be autonomous?
Doesn't have to be autonomous.
Okay.
So there's actually many ways in which it's an easier competition. But in practice, in the end, it's much harder to be competitive. Depends on how you look at it, I guess.
What's the objective of these robots?
So the objective, just like in the Lego competition, changes every year. But the basic premise is that you have a court or a field that you compete on. And instead of the size of a 4x8 sheet of plywood, it's the size of a basketball court, a little bit smaller than that. And they roll out carpet, and there's field borders, structural field borders that contain the robots, keep them from running off into the crowd. And then on the field, there's 2 alliances, one on either side of the court, and the alliances are made up of 3 robots. So it's 3v3, like in pickup basketball or something. And basically each team, a robotics team that you register with the program, is going to build 1 robot. But when you come to competition, you get randomly paired with 2 other robots and against 3 random opponents, at least for the first phase of competition. And yeah, your objective is essentially you get 2.5 minutes, and there's typically 15 seconds where the robots are autonomous at the very beginning of the match. And then the rest of the match, the drivers take control, and you drive them like they're little robotic RC cars. And you compete so that your 3 robots score more points than your opponent 3 robots.
And how do you score the points?
That's what changes every year.
Is there an example that you remember?
Sure, there's many examples. So in my first year on the team, I remember going to the big reveal, they call it kickoff, where they start the season by releasing what the game is, telling you what you're going to be doing this year, and giving people their like basic parts and whatever else they're going to pick up from the organization itself. When going to that, I really didn't know what we were getting into. I had really no idea what this program was about, except that it's building big robots, so I was excited. And the challenge was shooting basketballs into basketball hoops.
Cool.
Yeah, and I was like...
Full court?
Or
full size?
Yeah.
Let me check my camera real quick.
Yeah, I heard a click.
So you're shooting basketballs with robots?
Yep. So effectively, you've got robots that are kind of the size of people, you know.
And I think that needed to happen, and I'm going to let it just happen.
Okay.
I'm not going to worry about that.
Cool. So basically the robots, were playing with basketballs that were not exactly the same as typical basketballs that humans play with. They were slightly smaller, maybe a little bit smaller than a girl's basketball, and they were like solid foam, I think basically so that they couldn't pop, because the robots are pretty rough on them compared to humans. And but the basketball hoops were standard hoops, and there was one that was about at standard height. I mean, it might have been a little low, maybe 9 feet or something like that. And then there were 2 much lower at maybe 5 feet high, or maybe even a little less, 4 feet, I don't know. And then there was one real low, like 2 feet off the ground.
So it needs to be able to do each one?
No. So effectively it was, if you score in the high basket, it's worth 3 points. Middle baskets are worth 2 points. Low baskets worth 1 point.
Okay. And does it also need to be able to retrieve the ball from the ground?
So you can get the ball from wherever you find it, but the human player stations are where they're introduced to the field. Effectively, when you score a basket, it would go into the hoop and the net attached to the hoop, but the net was kind of connected to a tube. So the net would funnel it into a tube that would return it outside the field to where the drivers are driving the robots. Okay. Yep. And then there was a human player, which is someone who's like on the drive team, basically the team of people operating the robots, but they don't directly operate the robot. They handle the game pieces when the robots don't have them. So in this case, the ball comes out the chute, the tube, and then they collect the ball and then introduce it on the kind of the corner of the field through like a slot. And I think probably the design intent of the game designers was that the human player that returned it would be the human player of the team scoring on the opposite hoop. Because when you're driving facing the hoops that you're scoring in. And they were probably envisioning that robots would have to go over to where the human player is introducing the balls and then drive back across the field and score it again. Especially because there was kind of a barrier across the middle of the field that was like 6 inches tall. And that's a significant bump for robots like these to crawl over. And then there was teeter-totters that were placed on top of this 6-inch barrier that effectively they would sit flat on the barrier because it had a flat top, and it could tip one way or the other way, but they would normally sit flat, and the robots would have to like tip them down, drive onto them, and then tip them over and drive across. But anyway.
So they had to go through an obstacle course and able to get to the basket to shoot the hoop.
That was the goal, yes. But in practice, it turned out if you had a human player with some practice, you could throw the ball through the slot in just such a way that it would like bounce and curve and bounce and go over the bump in the middle of the field and get on the other side. So in practice, robots mostly stayed on the scoring side of the field, and then they would pick up the balls that were thrown there by their human player, with the primary exception being sometimes if a robot is not as efficient at scoring, they might go to the opponent's side of the field to try and slow the opponents down from scoring. It's really, you're just trying to score more points than your opponents. So subtracting a point from your opponent's score is just as good as scoring 1 point yourself.
Can you actually subtract an opponent's?
No. This is just subtracting from their potential,
yes,
right?
Fair.
Yeah. And so
just take the ball that they just shot and throw it back under the hoop.
No.
Get it to come back out.
De-scoring directly was not a mechanic in this particular game, although it has been a mechanic in the past. And every game is different, so you never know what you're walking into.
Do you have any experience with like the battle bots? Have you ever done something like that?
I've not done combat robotics, but I have been a fan of it and watched it like my entire life for sure. And
is that where like the big guys go? Like, let's go compete in the battle bots.
To some extent, it's definitely the expensive sport in like all the robotic sports. The robots are just extremely expensive because there's really no limits to what components you can use and how powerful they can be. If you were going
to make one, would you do one that has like a saw or like a stabbing component or a flipping component? Like, what's your ideal battle bot?
I've actually designed a few, to be honest, just kind of for fun.
And you're talking design it, not actually manufacture it?
Not manufacture, okay. Just like in computer software, designing it. And I think my favorite that I've designed is one that effectively has a weapon that's on what you might call a turret. It's like when you have a mechanism that can spin relative to the chassis of the robot. So like a excavator has a turret, or a crane has a turret. This is like a pivoting mechanism that takes one mechanism, makes it pivot relative to the drivetrain. And I think that would just be very interesting as far as shaking up the strategy of combat robotics, because a lot of the basic strategy right now is about like drive at your opponent and keep the front facing them. And that's something that you have.
And you want to be able to turn your front side, so to speak, 360?
Yes. So I want to be able to basically keep the weapon facing them, even if I'm driving perpendicular to that. Because it would just really change the types of maneuvers that you could do in the arena.
How are you inflicting damage on them?
So the design that I looked at had basically a horizontal spinning weapon attached to the end of something like a pole. I mean, it's not a long pole, but
are we talking like a spear mechanism? Like, are you spearing them?
No. So, well, I mean, kind of, but on the end of the spear is like, imagine a Beyblade. Okay. But insane amounts of power. We're talking like, 60 kilojoules of energy or something. The tip of it going at 300 miles an hour.
300 miles an hour makes way more sense to me than 16 kilojoules or whatever you said.
To
me, that's nothing. I don't know.
Yeah. And, it's it would be like a hunk of steel that weighs 50 or probably more like 30 pounds spinning with the tip going 250 miles an hour. And so carrying a bunch of energy by spinning so fast, and then being designed to where it can rotate and track the opponent and then deliver that kinetic energy into their juicy internals, ideally, but wherever you can hit them.
What's the other one that you designed? You said you made multiple?
So another one that I designed was a crusher type design. It effectively would have a ramp that you would wedge underneath the opponent, and then like a very strong upper jaw with a spike on it that would come down onto the top of the robot and slowly apply a very large amount of force to crush the frame of the opponent. And that one, I think, in hindsight, would not have worked very well. I had an interesting concept to use effectively a screw like you would use to anchor a large, like maybe like a traffic light pole. So maybe like an 1.5 inch diameter screw and nut, and then you'd spin the screw to move the nut that would power the jaw. And to spin the screw, I was thinking you could use an impact gun, just like what people use to tighten lug nuts in a garage. And the concept would be that impact guns are nice because when they're not under load, they spin very fast. And once they reach some resistance, they start basically behaving as an impact gun, and they can produce a lot of torque at a low speed. So it'd be kind of like a 2-speed shifting transmission. So it would close down on the opponent quickly, but then once it hit the opponent, it would apply a large amount of force and slowly work its way through the opponent. But I think in practice, having a really long screw that would be turned by the impact gun would be like a big shock absorber, and the impacts wouldn't be very effective. So I think the whole mechanism was a bit flawed in concept, but it was a fun idea that I catted up one time. But it's definitely, BattleBots is something that's on the bucket list. And I suspect at some point in my life, I'll probably be building BattleBots.
That'll be cool.
Yeah. I mean, like I said, it's something I've always watched and been a fan of and kind of aspired towards. But again, it's very expensive. And like I said, First Robotics is very expensive. I mean, there's lots of teams that run with a $50,000 to $100,000 a year budget.
That's insane.
Yes, which, for a high school program is really a lot of money, especially for something that most teams are having to fund themselves. But BattleBots, I think, is on another level. I think a lot of those things, there could be $50,000 of components on one robot, and then you're going to send it into the arena, and they could all be destroyed. And you'll just have to enter another one, which makes it extremely expensive. I mean, you have to basically come to the competition with at least 2 robots like ready to go, and then like another robot worth of spares. That's like $150,000 in pure parts. And then not counting into the fact that you need a really extensive machine shop more than you do for a First Robotics team, because it's heavier metals and more machining has to happen. And extremely expensive sport, but I think it would be very gratifying to compete in it nonetheless. I mean, there's something special about vaporizing large hunks of steel off of your opponent and throwing them across the arena when they weigh 250 pounds.
That sounds awesome.
Yes.
That sounds really cool.
Yeah.
Before we get out of here, I want to get I want to know some of your experiences in Luxembourg, what it's like to be out there.
Sure. Yeah.
I'm actually interested. How has your perspective changed on being an American, being outside of America?
That's a great question. I think it, at the very least, it's become clear to me that Americans are not great at learning foreign languages. Now, I'm mostly talking about myself here, but it just, there's so much English spoken all over the world now that it's really easy to kind of use it as a crutch and not learn any foreign languages, which is the boat that I am in. Just to be clear, I'm not outing other people that are doing it differently from me. I think that it's something that's a bit difficult to really get around.
Do you get any people who are surprised to encounter Americans?
Not really. No, I think typically there are just lots of Americans around the world is very multicultural and kind of a global culture in a lot of ways.
And you're saying there's a lot of Americans in Luxembourg, but you've gone other places in Europe aside from Luxembourg, correct?
Yeah.
And are you experiencing many Americans in those countries, in those areas?
Yeah, I mean, I think at least as tourists, you see them all over the place. I mean, Americans have generally a lot of money and travel is expensive. So you see a lot of Americans traveling all over the place.
Where are the other places that you visited in Europe?
Where are they?
Yeah, like what places?
There have been a bunch. I can't probably list them all off the top of my head, but I've ventured into Germany and France and Belgium and Switzerland and Spain and England. And yeah, where else? Italy. Yeah, probably missing some, but those are like the ones that are nearby to Luxembourg that are convenient. I've been to the Netherlands, yeah, and Denmark.
How many times, like, you're working, and then like how often do you go, okay, this weekend I'm going to go here? Like how often are you like doing like a little trip?
Yeah, pretty much as often as I can, which is usually, I mean, when I first moved there, I had a bit more energy for it, and I was probably doing every other weekend or so. And nowadays it's probably more like once a month or so. But I'm always planning something. My coworker that you alluded to, who also moved from America for the same project, is always definitely encouraging me to plan something, get something put together.
Is he saying, hey, plan something and I'll come along with you?
No. He's usually the one saying, hey, I bought a ticket to Portugal, are you coming? And I'm like, sure, hey, why not? He's just, encouraging of travel. And I think it's one of the big reasons that he moved to Europe. I mean, it's of course a big reason I also moved to Europe, but I mean,
so I went to the UK back in August, and I wish I could have gotten a chance to go into like the greater Europe, but I did go, I visited I didn't go to Wales, if you want to count that, but I did go to Ireland, Northern Ireland, Scotland, and England. And like airfare, at least in my experience, was way cheaper.
Yes. I have a theory that's probably more of a conspiracy theory that...
Let's hear it.
If you're trying to buy a flight, you should use a VPN through Europe. Because I think that even the same airline will offer the same flight for less to a European.
Interesting.
Could be wrong, but I feel like when I was first doing flights to Europe and back, I was booking them always from America. But then at some point I did basically a one-way trip, and then I was always booking them from Europe. And it feels like they got cheaper, even though there was like a ton of inflation in that time period. I haven't actually done the VPN from America thing to check, so I don't really know. But
I'm going to try that next time. I need to do it.
Yeah, definitely just flights around. The other thing is that stuff is close together. Exactly. That's something you really notice.
There's completely different cultures within a much shorter distance.
Yeah. Yeah, no, the cultures are very old and they're very close together. And it's really different to see comparing to America, where most of the culture is, like there's certainly differences as you go around the United States, but there's more in common than otherwise. And it's most of them formed at similar times from, similar kind of heritage as far as like the American side.
I got something for you. Of the countries that you've been, like, tell me which place has like the best food, which place has the coolest architecture, and which place has the best people.
Oh man, that is a tough question.
Start with architecture.
Architecture. Coolest architecture. How do you answer that question? I did like architecture in Prague. That was pretty cool. I think it's a bit of a tourist town. I think it's like a big part of their industry, and people like to make the buildings look a certain way, and it certainly looks nice. I don't know that there's really awesome individual standout examples though, but just the city in general was very pretty to look at. And then food, man, that's tough. It's just hard to remember, all the different food experiences you've had. I think
Sure.
Barcelona is probably a contender. There's some great Spanish dishes, get some really amazing seafood and paella, and I don't know, some really awesome food we had there. People is probably the hardest. I don't know that I can really answer that one, to be honest. It's just, people are also different.
Do you feel like how often are you making friends in these like new areas? Are you relating pretty well, or are you kind of like solo?
I think making friends has been a struggle for me. I feel like it's probably pretty much been a struggle all my life though, so it could just be a me thing.
Sure.
But I usually find it easiest to make friends just by doing things together. I've made some friends in Luxembourg playing table tennis, just something I like to do. And
is that like a local pub thing?
No, they have like basically community teams that just have open practice, and super fun. And
When you're doing your travels, are you staying in hostels or hotels?
we do hostels and we do hotels and we do Airbnbs. It's just kind of whatever is convenient. And we've definitely made some friends along the way in different locations, but I wouldn't say like I make a friend every time I travel somewhere, although that would be a good goal. Maybe I should endeavor to do that. But I think it's a bit difficult, you're just going around seeing a city for the first time to form that kind of connection. You're more likely, I guess, to run into another traveler probably than a local, but still, it's difficult with just a short amount of time. I mean, we're often spending a weekend someplace, and you might meet someone, say hello, introduce yourself, but it doesn't always end up really turning into a friendship. It just probably depends how much effort you put into it, I guess. But in general, meeting people is always fun in the different places nonetheless. So it's definitely worthwhile. I think the travel has been a highlight, but the work has been great too. So I definitely feel lucky to have the opportunity. I mean, I guess to go all the way back around to my journey to get here, I basically did the Lego League in middle school. I did the robotics competition in high school. I went to college locally, where I did just about as poorly as I did in high school, which is very poorly. And I continued to coach the robotics team that I was a student on, which I probably wouldn't generally recommend, because it gave me an easy way to distract myself from my schoolwork, which probably contributed to my poor performance in school. But on the other hand, it was while I was coaching the robotics team that essentially I met the guy who ended up recruiting me for this endeavor. I was just coaching his son, who was learning the ropes of engineering. And I do think that coaching a robotics team is totally worthwhile for anyone who's in the industry, has some experience. Even if you aren't in the industry and don't have experience, if you just want to learn about science and technology, or if you want to have an impact on local students, if you have some marketing, digital media experience, robotics teams need all sorts of people to run. They're much like a small tech company. And I think that's an interesting way to look at it. Yeah, they really prepared me for what I'm doing now to a large extent. And they also connected me to the person who would ultimately give me the opportunity. So I definitely have First Robotics to thank for my current career path, and I am quite thankful for it. Yeah, I mean,
is that how you would characterize your current employer as like a small tech firm? Like
yeah. So Flawless Photonics is very small, and they employ 20 or so people. And there's, I think, 12 of us in Luxembourg, really boots on the ground for the project that I've been talking about. And of course, the other people are in their own way helping with the project as well, just not so hands-on. So it really is a lot like a first robotics team. The primary difference is that it's honestly smaller. And there's less teaching of underlings because we don't have a bunch of students on the team. The robotics team that I was coaching was maybe between 35 and 45 students at any given time usually, and then maybe 8 to 10 coaches and adult mentors. And so that's just a lot more people than the company I'm currently at. And the company I'm currently at doesn't have a lot of really young engineers that are having to learn the ropes. So everyone kind of has their role and they're executing it to the best of their ability. And it also means that, just a lot of the things that you would use more manpower to do, things that you would like parallelize, right? You would like kind of get an assembly line going when you have some more people. We're not really able to do, which is a benefit and a disadvantage in my eyes. The nice thing is that as an engineer or a designer, I guess circling way back to where I gave my job title, I'm not called an engineer because I don't have an engineering degree. But effectively, I'm doing engineering work. But I'm also doing all of the hands-on stuff that has to happen to build this machine. So all of the design, but also manufacture and assembly and testing and finding the faults, redesign, remanufacture, retesting, assembly and documentation. Really, the people that are going hands-on with the machine are really taking on a large...
That's Vlad over there. Hey, Vlad.
a large kind of breadth of different types of work within the team, because we can't split it up by person, and we can't have like stations where people are working on different things at the same time. You kind of just have to push your work through from start to finish, which it is not super fast, but it also is really well integrated. And it
So you said your job title is not engineer. Did you say what the job title actually is?
Yes, so I'm a mechatronics and robotics designer. Yep. And I mean, ultimately it's an engineer that's not called an engineer, but
right.
It is a bit different than your typical engineering job. I mean, people who are listening to this who are thinking they want to get an engineering degree, mechanical engineering is the program I was in, and most mechanical engineers don't get a job like this. The most common thing is probably working in like heating and air conditioning design, HVAC systems for buildings and things like that. Because there's a lot of buildings out there, and usually they need some custom work to make sure that they're going to circulate and operate correctly. And that requires a mechanical engineer, so there's a lot of jobs doing that. Which, don't get me wrong, is also cool work, but it's certainly not what I'm doing currently. It's, I think, pretty different.
Would you say it's not even something you'd rather be doing? Like, you prefer what you're doing now?
Oh, definitely. Yeah. Yes. I knew from my time at First Robotics exactly the sort of thing that I wanted to do, because I was having a blast working in a small team, building a custom machine from scratch on a tight deadline. And that's kind of what I was looking for. I didn't know exactly how I was going to find that sort of job, but it basically landed in my lap, and I'm thankful for it.
Do you think that the tight deadline aspect of like the real world situation motivates you in a way that like a homework deadline didn't in school?
Absolutely. Yeah. No, the motivation is completely different for me. I mean, I'm not a psychologist, so I can't tell you exactly why it's so different, but to me, having a deadline that is basically put in front of you by someone who just had to assign a date is completely different from a deadline that is put there because essentially there are things that need to happen in order to accomplish the overarching goal, right? Like
And the overarching goal is so time sensitive because it needs to go on a rocket ship into space.
And the rocket ship will leave whether we're on it or not. So we need to get the machine ready, and we need to pass all of the NASA safety review and the verification requirements. We need to ultimately hand it over to NASA so that they can integrate it and make sure everything is ready to go, put it in the rocket. I mean, I think they want to have it several months, maybe was it 3 or 4 months ahead of launch for the integration process. So
I didn't realize that. I thought for some reason, you can tell me. I currently know that you have some sort of deadline in October. I don't know if that's a trade secret for you, but they need to have so October is like a timeline of like, you need to get it to us so that we can do our own stuff with it, so that we can get it up in whatever month they actually do it.
No, so we're hoping, well, I don't know if you'll have to cut this part out or not, I guess so. We'll find out when we review it, but October would be the launch, and then so we would need to have it.
You would need it done sooner than that?
Yeah.
Okay.
Months before that. So it's coming up really fast. So the deadline is tight, and that is something that First Robotics helped prepare me for. Honestly, like what we need to do in the amount of time.
Hey, that's the
camera again. So the deadline. Yeah, we're working on an extremely tight deadline, and what we're doing is much more unique, and the challenge we're taking on is much, I'd say it's more complicated, more involved, more difficult than what we were working on when I was in First Robotics. But the timeline is actually much longer. First Robotics, every year you show up with a robot and you compete. So at the very least, it's a robot a year, right? And this has been a 2-year project since I've been on the team already, and there were people working before then. But beyond that, the First Robotics season starts in January, and it's actually ending right about now with the World Championship. And it's actually, I'm leaving Wednesday to fly to Houston to see the World Championship because I was a competitor before. I think it's super fun to watch and see all the great teams competing, talk to the different coaches and students and see the different perspectives. It's just a blast to go to these kind of competitions. And I'd recommend anyone interested definitely to find a competition near you and check it out. But in any case, it's April now. So the whole season is like 3 months long, or maybe 3.5. But really the competitions begin like 8 weeks ago. And so you really need to have the robot completed and programmed and tested and have some driver practice before whenever your first competition is. But that could be as early as 7 weeks after you find out what the challenge is. And so the timeline is extremely, extremely tight and accelerated. And it's just like a rocket launch. The reason you need to get it done by then is there's a competition, and you don't have to get it done. You can show up with an incomplete robot, but you're not going to compete very well. So everyone's working together to try and make sure that when you show up, you have the best robot and the best team, the best performance possible. And what we're doing is much the same. We're all working together to try and make sure that we send something to space, first off, and that what we send is going to be success. And to me, that's really exciting. I really love that sort of stuff. And it definitely keeps me motivated, without a doubt. Yeah. Was there anything else you want to cover?
I think we spent a good amount of time here.
Yeah, it's a
I think
pretty
I'll let
long interview
I think
already.
I'll let you go out of here. Well, Bryce, thank you for coming on, and I'll see you soon.
Yeah, thanks for having me. It's fun. I always enjoy talking about this sort of thing. It's really, I think, life is about finding your own path. Mm-hmm. And I'm quite happy with where I ended up. I don't know that it's a route that it would repeatably be so easy to emulate, but I do think there's things to learn from it, things that I try to learn from it, and hopefully others might find it interesting as well.
Mm-hmm. Well, we're going to go ahead and assume that you had a success on this mission, and once you're back, I'd love to hear how this went. Yeah. Hopefully next time I come, I can definitely talk more about the specifics of what the mission scope is and what the results were. Mm-hmm. That would be very exciting. So I'm excited for you.
Thanks.
Yeah.
I look forward to it.
Thank you.